Hello, I'm Jan Baan, and I'm invited for a podcast from the famous ERP doctors, Dan Eldridge and Sam Gupta. And they asked me to explain some things about ERP as the engine for composing. Now, what means that for composing apps, that means it's not composing ERP, but it's ERP as an engine. You decouple it because it's a transactional system, most times a legacy system. And what you do then, you connect it to the new world, to the world of the human, to the work of the workflow, and there you downstream, you then improve all this functionality. But first ERP, and even what I know is Baan ERP, because I'm Jan Baan, I'm the founder of Baan Company in 1978. 20 years later, in 1998, Eric Keller from Gartner mentioned that we have four leaders, call it Bob's, Baan, Oracle, PeopleSoft, and SAP. And from these four leaders, they mentioned that SAP SAP is the biggest one, but Baan is the best one, the most innovative company. Why? Because I think it came most from our winning element of the Boeing deal. We were winning the most famous deal in mid-90s last century, and it was the Boeing deal. 40,000 users bringing everything together on one instance. And we could win because our functionality were by far on top of an Oracle and of an SAP in the logistic functionality. Boeing takes off with a Flying Dutchman. And why could we win? Not only on functionality, but we were able to invest to demonstrate in 3 days for 400 people. And we came there with our pre-sales people to demonstrate, but we came there with the lessons learned from boundary spanners. And what are boundary spanners? Now, boundary spanners are spanning boundaries. The boundary spanners are bridging business and IT, aligning IT and business. And already in the mid-90s, we have our Baan Institute, PBITS, and it was a mini MBA course where we selected the best people around the world, sometimes 60 people in a class for a couple of months, came from Australia to Japan and Singapore and China and America, etc., and the Nordics and Germany and the Netherlands, all united together learning this one, and aligning business and IT became the focus of the boundary spanner. They spoke the customer's language and knew how to ERP solutions could value to the customer's competitive advantage. They should understand EBITDA, what means it for the real business. The school quickly became very successful, and in 1997 already had 270 graduates. Now, one of the first students was Dan Eldridge, and I believe we propelled him in his career where he is today as the ERP doctor. And I feel still I have a credit, a little credit to this one, because and you can explain it more, but being there a boundary spanner is famous. And these 270 people are in the boardrooms worldwide and dealing there with. Okay, now what means that then if we go to this one, then we learned that even the boundary spanners, but even they are what should I say, propelled with the Baan tools. In the curriculum we learn them a lot of the Baan tools, and they're famous. The most famous elements are maybe hidden with the Baan tools to build a Baan company. And in tools, we are able very early, or in the early 80s, where we had a basic language, Star Basic, and building our first applications in an, say, proprietary solution on microcomputers. Now, we built our famous Baan shell, and the shell we are able to decouple the applications and execute them, etc. And we are able to generate the shell. You have to enter this one with a C language. That means we convert all our programs converted into C, and we did it continuously. That means we have the productivity of a pseudo language who became event-driven, step by step, like Java. It was like Java today. We converted to C, and we're executing this one. And then later on, we built even our customization with query. When we had the query SQL was good for the consultants, and the report generator good for the end user, building an information system and having our peripherals. And this BMCS system, early in the 80s, our first manufacturing solution, more an MRP2 solution, was already divided in many interesting areas. The master control, master production scheduling, material requirements planning, decoupled from the data collection and cost accounting, item control, stock control, sales purchase. We mirrored them together as one element First, the core was the same, and then you focus more on procure to pay or other elements or real in quotations etc. sales and have them together. Group technology, product control decoupled from ERP, shop floor control. Now, an amazing piece of technology with the shell, and the shell became more advanced later on. We improved this to a standard program in the 90s. And it means we had our DALs, our data, famous data access layer, and there we have our 4GL environment in the standard program with the DALs, where we can deal with every database. We have our user interface. We could do ever graphical stuff in the UI and bring them together, decoupled. And we have our standard program combined with the data dictionary and the forms. And this standard program was like Java, immediately could be executed to the shell. And this Baan shell was still famous, and then we built our dynamic enterprise modeling for the implementation tools, Baanwise, what was also the winner, where we could win the Boeing deal. And it was built a lot with the input from the boundary spanners from our mini MBA class. They really were focused on also this implementation methodology. And then we had the input for C++. Now, I tell you a secret. Why is it that Infor is one of the earliest going with ERP good on the cloud with this rich functionality? Now, what they do is they bring the same functionality what we built in the 90s, we bring it over automatically to the cloud. The CPU, you can replace it to the cloud. And the operating systems, bring them to anywhere in Amazon or bring them to a Google, where we go extremely deep in these elements and these databases with BigQuery, etc. Also isolated them and link them, and we have same stuff therein. That means all the source code built in the 90s, and if you give you an example from my brother-in-law, Jan Hasselman, famous what he built, this product configurator, this masterworking scheduling, very smart code. No one ever, people from Infor mentioned me, could do what Jan Hasselman could do in the early days. That means all this code is still there. And it's too hard to replace these codes and do it again in C++. That means it's only a question of executing. Now, what is then amazing stuff? That means the same functionality could be transferred to the cloud. But what is in cloud? It's done in the cloud. It's not native cloud. It's done in the cloud from a legacy ERP vision from last century. We had already what Java did before as a kind of a Java with our standard program, but there was one element missing. It was extremely strong in the DALs with all this database, but it is still not object-oriented. It's event-driven. Now, and that is have its limitation, although it's good enough, and we built everything here. Now, and then what Infor did around this one, they built a middleware, and I should say the middleware is so-so. It stinks a little. They are not smart in this middleware. There we did much most in the BPM layer, instead of only this little XML stuff therein. It's my opinion. A little critical therein. Now, but this is amazing, but they destroy a little bit the middleware. Now, what they do with the middleware, now we built amazing stuff. You see Baan 4, and if you look to all those stuff, business planning, innovation, masterworking, scheduling, requirements, planning, purchase, sales, going there and decoupled points, show you a little more. Here you see this famous customer order decoupled point. Engineer to order means you do only generic till the order, and then after this one you do all customer specific. If you do make to order, you go a little further and make it, and here the generic part is coming here to the specific part where you have your project control system. But why should you store all your inventory? You have not to do it here. You need only the invoice and store it here. If you go to assembled order, we need a product configurator and how to deal all this stuff. And you go to MRP, totally generic, all those warehouse stuff, and bring it in, and the decoupling point is only here, or repetitive processes. Now we could do all stuff together from a product based on forecast to a production based on customer order, mix them all together. Now, famous to do this, but I mentioned already what was not so good, and even in Infor is doing not the middleware stuff. Now we built a famous middleware in Chorus and say, okay, let ERP stay where it is. Only the customer engagement, the transaction element, business transactions, contract fulfillment, customer service. And then you build your middleware is totally a BPM layer. And later on a little more in detail, we build our business process management element. Now, browser-based. This was only transaction-based in last century, and the UI was they're only ASCII. Now we moved to real the focus in the internet, your mapping, the user interface, the rules. You can change 1 second before the transaction, you can change the rule. Here the rule is stored in concrete to all the business element in even the logic. Now that is even very less flexible in it. Now we were able to, but we model it to end-to-end processes in a beautiful, this generated, totally automatically generated from our BPM layer, automatically by the computer. In our real nice slim lines is a transactional layer, but it's also a case management layer where we came in later on a little more. It was famous, and we built it in our business operating platform, a platform. As the business decoupled from this legacy system, we adapted these legacy systems here and bring them in a grid, in an enterprise service versus business service to metadata. You have one database, you have maybe 20 databases on metadata all united together. Then you go to the second layer, the business process management suite with case management, where you have a transaction layer and a case management layer totally together. The more you go downstream, the more the human is coming involved. And then you do then document management. You cannot integrate them. Now, we integrate them already for 20 years. The rules decoupled, business activity monitoring integrated, and I move to the composing layer. Composite application framework where you do your task, your workflow there. Now we did it in 30 years, and we quit it again, and I moved here from system of records in this beginning of this year to system of differentiation. I burned again my ships, this part of open text. I moved a big step forward, and what we called and let me explain a little what we do there in the core element of the internet. ERP, I mentioned already one database, still a relation database, built before the internet. Have no clue what internet means. On Unix system of records. We burned our ships, started again on the internet, and built this rich, say, middleware element. That is my blaming a real info in the middleware. It stinks. It's not professional there, and it's by far too complicated. You should avoid this one. The backend is beautiful. Now, here you can bring all the processes end-to-end together, end-to-end to the whole enterprise, and you're connecting it with the browser. The browser is connecting the dots. Here we move a step further to big data, and we have the REST API. Instead of doing these complex things ourselves, this already a bespoke, it's already a consumerized product available, everything what we see on the mobile. Now, this REST API is famous, where you can do all this case management stuff. And we burned our ships and we moved in Vandenberg, because it became part of OpenText. And for the third time, with the newest technology, with Google, we went extremely deep with the REST API, with big data, and you see here the data elements. Every ERP system has no big data. What means that? That means you have only the data from today, or no longer from yesterday. Everything you change, you lost it. In big data, you bring everything together and you take all these algorithms and even have meanings out of it and learn from it. Now, then we moved what we call to the intelligent layer, from data to information to knowledge. And then we bring it intelligence to bring all this AI, generic AI opportunities, and building it with Kubernetes, this containerization in small elements. We go from big data to semantic data. That is real if you go to digital. Digital should be dynamic, semantic data, event-driven, and one version of the truth. You bring everything together, integrate them. That means here we're building our famous microservice, very robust microservice with the rapid developer. We do it 4 times faster than a Java programmer, generating 80% of the code, making our dynamic workflow with the co-pilot evolve based on big data, on BigQuery, and the last mile we take every Internet of Things element in the dynamic workflow to improve the productivity of the knowledge worker for the job to be done. This is where intelligence gives you suggestions, but it is where on the end is still the driver is doing. The metaphor is maybe semantic cars, or say autonomous cars. Now, it takes long before you can sit in the car and say, bring me home, and I'm sleeping and wake me up when I'm at home. No. You should be alert. You can read a little, but to a certain point, you have the steering wheel. Now, still the steering wheel is there, what you do by your hand. It's still the knowledge worker with AI combining it. The driving element is 5 times better that you can do by hand or anywhere yourself. In this Tesla, we see all this data, but the last mile is done by the human. That's still what we do. We call this the wisdom. Here, we don't know. We give you suggestions. You have to go here, but the way how, you do it yourself here. Maybe you take this route instead of this route. It's a job to be done from the knowledge worker. That means, to a conclusion, disruptive business applications for, again, what we continue to do. That means we are adopting these legacy solutions from last century. Are they on the cloud, on premise, doesn't matter. And we improve them to the composing layer, and we make this composing layer as the Internet of Business. Everything should be on the internet. With Google, very in-depth, high productivity coding, software productivity suite on Google Cloud, generating 80% of the code. But here you should not talk with the machine. Here, totally not. That means the machine to machine or things to things integration can be the last moment. You can do it on the moment when only this composing app is in the hand of more even what we see in the where the people in the instructor who is dealing with the machine, etc. And the operator. Now, only the operator, just 2 seconds before he starts the task, need the communication of the IoT stuff therein. That reduced tremendous with late binding this type of applications. Instead of doing it here, it's 1,000 times too complicated. And here you build real dynamic workflow solutions for the latest moment, where Peter Drucker mentioned already, the knowledge worker. Have everything on here, everything integrated. It's twice more productive. It means you bring more to the EBITDA. Okay, let's show that in the future, where composing apps can contribute a tremendous amount of money for the EBITDA and makes the knowledge worker at least 2 times more productive. Thank you very much and see you next week.